Hello everyone, and welcome to an experiment with Sweet. I'm Sake, and today we're going to be doing an experiment with pressure. The experiment we're going to be doing today has to do with not only hot water, but also glass bottles, so it's really important that you get an adult supervision if you're going to do this at home. Pressure is a measurement of force over area, and one of the formulas you can use to find pressure of something is the ideal gas law. Now, I'll explain more about this after the experiment.
For this experiment, we're going to need a thick glass bottle, a pot of hot water, and a pot of ice-cold water. What are we going to do? We're going to pour the hot water into the glass bottle and allow for the glass to heat up. Then we'll put the glass bottle upside down in the pot of ice-cold water. Now, let's guess what's going to happen with the water level. Will it stay where it is? Will it rise to stay at the same level as the water outside of the bottle? Or will it rise higher than the water level of the pot? Whatever your hypothesis is, hold on to it, because we're going to test it.
The first thing we're going to be doing is heating up the water. We want to bring it to a simmer, but not make it too hot. I'm actually doing that right now. Now that our water is nice and warm, we're going to pour it into the bottle. And now we wait for the bottle to warm up. Now that we've waited long enough, we're going to use a towel to pick up the bottle and empty all the water out of it. Now we take our warm bottle and we put it upside down into the pot. I'm using a Pyrex container because I want you guys to be able to see it, and I'm also using water with some food coloring added, again, so you guys can see it. Alright, and as you can see, in just a few minutes, the water's been pulled up all the way to the bottom of this label.
Why did the water level rise? Let's think about that equation that I talked about before. It's called the ideal gas law, and it explains how gases act. The P represents the pressure of the gas, the V represents the volume of the gas, the N is the amount of substance, and R is the ideal gas constant. This changes from material to material, and the T is the temperature. Now, let's only think about the air inside of the water bottle. And let's think about the variables that are allowed to change in that formula. The pressure and volume can change, but the amount of substance can't change because it's an enclosed space and no air can come in or out. And neither can the ideal gas constant because this depends on the material and the air is not changing anytime soon. The only thing on the right side of the equation that can change is the temperature, which will decrease as the air inside of the bottle cools down. And since the temperature is decreasing, either the pressure, volume, or both must decrease. Let's go another step further. Is the pressure or volume going to change? Well, what will happen if the pressure changes? If the pressure goes down, the force of the air on the water inside of the bottle is going to go down too, which means that the force of the air pressure outside on the rest of the water outside of the bottle is going to be able to push some of the water into the bottle. And as this happens, volume will go down and pressure will go up. And if the volume is going down, that means that the air in the bottle is taking up less space, which means that the rest of the space is being taken up by the water. And that's why the water ends up rising in the bottle. Thank you so much for watching. Be sure to like and subscribe so you can stay tuned to our latest videos.